to start off with, let's just start with simplifying the square root of negative 9. Well, remember that if you have a negative inside, you have to break it apart because technically it's not possible. And what we do here is we're going to write this as the square root of negative 1 times the square root of 9. Alright, now I know the square root of 9, and you should know now that the square root of negative 1 is I. This is not a real number, this is an imaginary. So what I basically get here is I'm going to cross that out and call that I. I'm going to cross that out and make that a 3. So what does it equal? I'm going to call it 3i. Kind of like 3x. You don't write x3, so we'll put 3i. Now, technically, this is impossible with normal number system. But we're adding something called the imaginary and letting us keep going. So if that was your answer, same idea. All right, can you tell right off it's an imaginary?
Yeah.
But can you break down the square root of 8 as well? So these are kind of like end results of a test question, like a x squared equals, you're solving. So, but for this one, we're going to break this one down. So the square root of negative 1 and the square root of 8. But the square root of 8 keeps breaking down. What square number goes into 8? 4. Looking for square numbers. And so is that simplified? Does 2 break down? No. The square root of negative 1 is what again?
I.
So let's call that I. The square root of 4 is what? 2. And the square root of 2 is just the square root of 2. So now I have an I and a 2 outside the square root. Don't we normally put those in front? And we're going to write it as 2i, and you have square root 2. The reason, again, we don't put the 2i behind is you might think it's inside the square root still. So we always, anything that comes out of a square root, we stick in the front so we don't possibly think it's inside. It's just a way it's always written. Now let's look at these top numbers here. I equals the square root of negative 1. We have to learn what I squared is. Now, do you guys understand when you square a square root, think about that for a second. When you square a square root, doesn't that just drop the square root off? Like if you have the square root of 9, that's 3. 3 squared is 9. Okay, so if I'm just squaring this, are you guys okay that it's just going to be negative 1? When you square a square root, it becomes negative 1. And that's important later on. Okay, now the next one. What about I to the third? Well, do you guys okay with I to the third is I times I squared? Are we okay that I to the third is I times I squared? What's I squared? So could I write I to the third as negative I? Since I squared is negative 1, can I just write I cubed as negative I? And it's going to be important. Let's see. I to the fourth. Are you okay that I to the fourth equals I squared times I squared?
Yeah.
And what's I squared? So it's negative 1 times negative 1. 1. Now you might be, why am I writing these all out? You'll see down here. You'll see in this problem right here a little bit. You have to know these. And by the way, I to the 5th is the same as I to the 6th, I to the 7th, I to the 8th, I to the 9th, I to the 10th, I to the 11th, I to the 12th. It has this repetitious pattern. If you kind of just keep breaking it down. You just, as long as you know this pattern, you can get I to the 5,000th. If you kind of just broke down the pattern. But just understand the basic structure of creating these. Now, to add and subtract imaginary numbers, all it's doing is combining like terms. Think of the i's as x's. And just combine them. Think of these i's as x's and combine. Because watch, you'll be like, oh, I remember that. If I have a plus, can you just drop the parentheses?
Yeah.
Now, oh, by the way, imaginaries are written like this. Imaginaries tend to be, a lot of times, imaginary has a number plus or minus the imaginary part. This is also imaginary, it just doesn't have a number in front. But you see these are called imaginary numbers. This is kind of how they're written. They're usually has an imaginary part and a real part kind of all together. Anywho, so let's just drop the parentheses and combine like terms. So all I'm going to do is simply, it's actually really simple. I have that, and then I'm just going to combine the like terms. So what do you get when you take negative 6 and 7?
1i.
So you have 8 minus I. Done. It's fairly simple. Because don't you get negative... Oh, it's plus I, right?
Yeah.
Because won't negative 6 and 7 become a positive I?
Yeah.
Is that right?
Yeah.
So it's positive I. Because a 7 and a negative 6 is a positive 1. 8 just stays. So I added 2 imaginaries. I got a new imaginary. So with this one, can you picture distributing the negative though first? On this one? So if we're here, we got to distribute this negative. Because with minus, it's a little bit more complicated. So you have 2 minus 3i. And then that becomes a negative negative. It's a positive 5. And a negative 6i. And then can you combine like terms? So we're going to combine the 2 and the 5. Doesn't that become a 7? And the negative 3 and the negative 6 becomes what? Do you see how we took 2 imaginaries, subtracted them, got a new imaginary? So to multiply 2 imaginaries, all we're going to do is FOIL it, or use the box. That's all we're really doing here. It's just like a basic FOIL problem. So I'm going to go 5 times 4, and then 5 times negative I. So 5 times 4 is 20, and 5 times negative I is negative 5i. Okay? And then I'm going to multiply 3i times 4. It gives me 12i. And 3i times negative I is negative 3i squared. So, there we go. Now, we just got to simplify it. But as we simplify this, do you remember up here, what does I squared equal? Negative 1. Because don't we want in the end no I squareds left? If you ever get an answer with an I squared or I cubed or I to the 4th, you want to change those back into i's using these numbers right here. So can I replace this with negative 1? Can I combine these two? Watch what happens. I'm going to combine those two. First, I'm going to leave the 20 in front. Negative 5 and a positive 12 is a positive 7. And won't this become 3 times negative 1? Because I squared is negative 1. So I now have, that'd be 20 plus 7i. And what's negative 3 times negative 1? Is that plus 3? Now can I combine those? When I combine those, do you see how you have 23 plus 7i? Now again, it's the same process, except anytime you have an I squared, you have to change that into a negative 1. And then once you change to a negative 1, it combines down, so all you have are numbers and i's. Again, always you want to end up with numbers and i's. So, if I want to do this one, do you see how to simplify this first part, do you see distributive property? And to simplify the second part, do you see another distributive property? So here we go. I squared times 2 is 2i squared. And I squared times 3i is 3i cubed. Then I have a negative 3i squared times 5, which is negative 15i cubed. And a negative 3i cubed times 2i, which is a positive 6i to the 4th. So what we first did is we distributed the I squared to these and the negative 3i cubed to these. Now can we combine like terms and then change all I squareds, I cubes, and I fourths to what they appropriately should be written in simplified form as? So do any of these combine right off? Can you tell these two are going to combine? And then can we replace I squared with what? negative 1. And I to the fourth gets replaced with 1. So let's go and replace things. 2 times I squared, which is negative 1. We're going to combine these. What do you get when you combine those? Negative 12?
Negative 2.
Is that negative 12?
Yeah.
I cubed. And then the last one over here is going to be 6 times, what was I fourth? Is that 1? Now, can we still get rid of I cubed? Isn't I cubed negative I? So 2 times negative 1 is negative 2. I cubed, we said, is negative I. It's on the top. And 6 times 1 is positive 6. So that becomes negative I. This is simplified. This is simplified. Now, do you see how it's going to be a basic imaginary now? Can we combine the 6 and the negative 2? That gives us 4. And then negative 12 times negative I is positive 12i. All that, we got imaginary out of it. The key again is doing distributive property and then breaking down any higher powers than I using these 4 ideas. And in the end, you got your imaginary. That's what we're looking for.